Welcome, everyone. Today is Wednesday, the 25th of February, 2026, and this is the SIG Cloud Provider office hours. SIG Cloud Provider is a sub-project of Kubernetes SIGs, and as such, we follow their meeting guidelines, which can be summarized as please treat everyone as you would expect to be treated, or explicitly so, please be kind to each other. And if you'd like to talk, please raise your hand and I will call on you. Alrighty. So, at the beginning of our meetings, we like to give a little time for sub-projects to give updates. So if anybody is here representing a sub-project and would like to share things that are going on, please, feel free to raise your hand and I'll call on you. And I guess if anyone, I encourage everyone to add themselves to the attending list so we know, how well attended these meetings are, if you feel so inclined. All right, I'm guessing we have no sub-project updates. So we will move along to our agenda. Ryan, I see you've got something about the specialized lifecycle management and declarative node maintenance stuff. So please take it away. You are still muted if you're attempting to speak, Ryan.
Oh, whoops. Okay. I
There
said,
you
oh,
go.
hi everybody. There we go. Hey everybody. Would I be able to get the screen share capabilities from you, Michael?
Yeah, absolutely. Let me make you co-host here.
Thank you. Excellent.
All right.
Okay. Perfect. Well, I get set up. So I'm Ryan Halsey. I'm from Working Group Node Lifecycle, and I wanted to share with you all a KEP that the Working Group Node Lifecycle is working on because I think it would be relevant to many of the folks here and some of the work you all do. So this KEP, I'll dive right into the context, which is the starting with declarative node maintenance. So the history here of this KEP called specialized lifecycle management is actually begins with this KEP here. It's called declarative node maintenance. And at a high level, I mean, I'm sure it's self-explanatory. I think we all kind of know on a what node maintenance is. It's various lifecycle things we do to a node. This KEP specifically was focused on creating an API around doing node maintenance and having that be something that's in tree in Kubernetes and have a natively supported API. So nodes improve the tooling around doing life cycling of nodes. Now this KEP and the scope of this KEP was very focused on a node and where and so what happened with this KEP is that while this was being worked on back in 2023, DRA was also being worked on in parallel. And that's significant because think of DRA sort of has, or DRA sort of redefined the paradigm of scheduling, and with it, it sort of changed the identity of a node, and so we sort of had people asking us the question, what is a node? Now when you think about DRA, um, think about this concept of allocating bandwidth, for example, right? You could allocate bandwidth to a pod and from a switch, and that switch might not be a node. It might not be running a kubelet, but you can attach resources to a pod. So it's almost a very different concept entirely, where the node has sort of become disaggregated, the resources of the node. You can take any device and we can have it as an advertisement and we can allocate it to a pod. And sort of like the crux of this is like if you think about scheduling, when you think about a node and sort of I'd say in the past, and that we've been allocating pods to nodes, but when the DRA world, with the way that it has sort of disaggregated things, um, we're now allocating and scheduling or allocating devices to pods, resources to pods, and then you could also say that we're also that the node is one of those resources that we're allocating to the pod. We're allocating a kubelet to actually run that pod, and so it's sort of like a different way of thinking, and that has been introduced as a part of DRA. So all this to say, this KEP was focused on the node resource only. And um, sort of the part where it got stuck is that we wanted to change the scope. We wanted to expand the scope. We wanted it to include any resource API. So a node or any of the DRA resources like resource slice or whatever. And then anything we could think of in the future. There's so many changes that are coming in with like the workload API. We're sort of rethinking like how some of the scheduling is happening. I mean, we don't know like what else might come about, from whatever the use cases that are coming in from DRA. It might change like how we handle these different resource APIs. So we want to be more flexible. So we want to expand the scope. Um, so that's the background for this and why this KEP has been around, why it's important, and sort of the precursor to this KEP that I want to talk about today, called Specialized Lifecycle Management. So this is an expanded scope of what I said originally was doing maintenance on a node, to expanding it to think about it as doing maintenance in sort of the general sense on different resources in Kubernetes. And so the high level sort of pitch for this is that we want to create a standardized declarative API for coordinating lifecycle management. And particularly this with the scope, the design took a slightly different turn in that we wanted to learn from some of the existing patterns. And so the focus, and you'll notice if you go through this KEP that there are similar patterns here to what has been done previously with PVCs and DRA. And specifically, the thing to take away from that is that DRA and PVCs, like those frameworks, have this concept of a driver, right? There's this driver that runs on the node, and it has this understanding how to slice up a device. And for storage, like we're taking storage, we're allocating some piece of storage. For DRA, we're allocating, say, like a GPU or something. And what's interesting is then this framework is these drivers have this gain this concept of advertising capabilities that they can support. And so like a DRA driver for like an H100 can advertise all of the different capabilities of that it can support and to allocate this different ways that it can allocate this H100. And so what's interesting is like it creates sort of this vendor ecosystem, right? We say like these are vendor drivers and that they have very specific business logic in order to decide how these devices and stuff gets allocated. And so what's interesting is about this pattern is that in this KEP is that we actually want to reuse this concept, but we want to change this idea of instead of doing it for devices, we actually want to do it for lifecycle management. And so the high level of that is that instead of I want to allocate a pod and then I want to allocate a GPU of this type in this way using this driver. This concept, this KEP, talks about this idea that we want to have we want to use a life cycle, we want to go through a life cycle transition for this node. And the driver will have some sort of understanding of what that transition is. And so a transition would just be like a state change. So another way to put that is a driver understands how to change a state for a node. And so if you think of like a good example of this that I think would be relevant here is like draining. We go drain is a very common thing that nodes go through. I mean, everyone would understand what drain is, but drain is sort of unique in a sense that like it's based on different providers, environments, hardware, and context specific scenarios. Drain could mean all these different things. And so what's nice about this framework is that we could provide the ability for some vendor to uh, to decide how they want to enact a drain. And so they could have very context specific business logic in a driver, and then they could use a common API to advertise how they would do their drain, right? So I guess I'll put it this way: is like you'd have a driver that can do drain, and it could be very specific to your provider, and then but you'd have a certain way to allocate it, just similar to like with the way we do PVCs and similar to with way we do DRA. There's one standard to describe that capability. So that's the kind of the link to DRA here. Um, and so the idea is that we want I'm targeting this KEP for Kubernetes 1.7. So I wanted to get the feedback and get the interest of the different SIGs. So I've been going around and talking to the different SIGs to get all your feedback. So um, I just wanted to get if there was any questions. There's one more point I wanted to make, but I wanted to see if there's any questions about the context so far.
Well, if nobody else has questions, I have some thoughts and questions. And Ryan, I've been following this in the Node Lifecycle Working Group, so I'm really appreciative of you coming here and kind of sharing this with the wider audience. Um, I think like from a lot of what I've been reading about this, like it totally makes sense to me. I think the direction you're going, especially with the new replacement cap, is really interesting. From the perspective of like wearing my SIG cap or whatever, like. I think where this SIG probably might have a lot of interest is kind of in that crossover realm where like a cloud provider or the infrastructure provider might be trying to provide some sort of signal that they're going to initiate, node lifecycle or something related to that maintenance. Then there might be opportunity for like a crossover there between, the controllers that we maintain and kind of how it interacts with this node maintenance. But I would expect in other cases that most of the things that we're looking over will hopefully just kind of slot in normally with this, and there won't be any sort of disruption to that. Although I could see, once this API is created, there might be opportunities, to improve the cloud controllers based on what they're seeing in node maintenance, like node lifecycle skipping things in maintenance and stuff like that. So that's kind of my initial thoughts, at least.
Yeah, that would be the goal. We would want a lot of like because there's so much tooling out there. I mean, there's so many projects in the ecosystem that are doing node lifecycle or even just whatever lifecycle in various different ways. And so we wanted it to be familiar. And I think the other part is like we wanted to sort of provide like I call the canonical API, like sort of we want to provide some relief in a sense that um, someone else who wants to build their own version of this, their own lifecycle controller and stuff, they would have to go through similar steps that probably everybody else had to go through to build an API or an interface. To describe the lifecycle states, and then they'd have to have a controller that goes through these various states to orchestrate it, and then I mean, there's so many projects we could point to that do this, and so the idea is that we want to reduce. We don't want everyone to have to do this. We can point to we all end up doing the same thing. We can come up with a common API for it, and then if we do come up with a common API for it, then we can have some interoperability across these projects. And that's one of the other things in this step that I focus on in terms of the why is like there's a lot of fragmentation in the ecosystem. Like if you had the cluster autoscaler, like does it work? Does the cluster autoscaler work with NPD today without any work that needs to be done? Can my own project that I use work with NPD without writing some sort of logic to translate between the two APIs? And that's sort of like the challenge is that the interoperability is very limited today. And where this goes is like if we have this interoperability, then it enables things like the really complex case of like that I always go to is like how do you life cycle like a 50 node workload using the workload API? Like how do you life cycle? We just allocated 50 GPUs off across 50 nodes. We also need to life cycle it, and you have to be very precise with those APIs and how we life cycle it. And so how do you do that? How is it expressed? So the scheduler has a sort of vested interest in these concepts of lifecycle management, right? And so not only is the scheduler, like I said, all these other projects do as well, and so they would benefit from a single API that we can understand and recognize where lifecycle management is happening.
Yeah, that makes a lot of sense. Derek, you've got your hand up, please.
Yeah,
Oh,
I got a question for you,
Walter, I'll put you
Ryan.
in queue.
Um, so the whole like I get the idea of like everything needs to do this kind of life cycle management. I guess my questions are, so because you are having the idea that you can have interoperability where multiple different controllers are taking on various life cycle events, how are like do we have line of sight on how we plan to handle like the distributed locking case so you don't end up with like flapping in general, where it's like controller A thinks they want to be moving it towards this life cycle, but or this life cycle event, but controller B thinks they should be doing it that way. Is that just like on the implementers to figure out how to not race with everybody else and to not fight for contention? That's
Yes,
my
this is a
first
great
question.
question. Great. Okay, well, let's start with that one. So this is a really good one. So this is a good one because we have to design the architecture such that it's very clear that a driver, in the sense that that I described it earlier, can understand that it is handling the life cycle of whatever it is it's life cycling. So we'll just say node for simplicity. So that there would be a driver that so this driver understands that if we require a drain, then that driver needs to know that it should be the only one that should be going through and doing drain. So I guess the example I would go point this to is that think about in like on the DRA side with scheduling, the scheduler, the role the scheduler plays in allocating resources. We have a physical device, a GPU, and we want to attach a pod. We're going to get a pod that uses that GPU. So we have a scheduler. We have two requests for pods on the same node using the same device. One of those pods will get scheduled. One of them will sit in pending. It will fail scheduling because it will the only one of them will be getting the device. So essentially, like that idea that we can make these things serial, um, we basically want to copy. So where I'm going with this is where this KEP wants to go is that we eventually want to actually schedule these life cycle events such that the drivers can process these events serially and have control over what it is they're working on. So they don't have to worry about is another driver doing some other sort of life cycle management operation at the same time.
Okay. I think that makes sense. I mean, you still have the problem of like, I could easily see this problem getting separated into like, there are things that produce life cycle events and there are things that consume them. And saying like single tenant consumers, but multi-tenant producers still has a problem of like, how do you reconcile? Like, you kind of need single tenant both, or you need to have this kind of serialization locking mechanism. And um, I don't know if that's easily solved with Kubernetes APIs because they're not very consistent. They're not strongly consistent, I guess I'll say.
Yeah, this is a tough problem. Like I said, I think that's how we're looking at approaching it through through the scheduler side is that we would try to serialize that way. For like multiple read like the idea is we eventually have multiple readers. We hope to not have multiple writers. That is an area that we will think about because again, like I'll go back to DRA. Technically, you could do this in DRA. Like you could have actually like like a device can get split up. It's called I can't remember the name of it, but like if you had a single device, it could be advertised as both a physical or a vGPU, and you can have two people come in and grab the vGPUs at the same time, and they can also be allocated. So we're going to actually, my goal was to follow some of the similar patterns here, but that is definitely a challenge that we have.
All right. And then my second one, which maybe is a fairly basic question, why is this different from spec and status? So like we already have the declarative spec API for objects where you say like I'm going to set this field and the status represents where it's actually at. Like why do we need a separate set of APIs for tracking like workflow events when like the edit history of the spec is that? So you can already declaratively say I want this in this way and then the status is like to represent where it actually is. Like, why isn't this just like a more standard field that goes into the spec and status?
Okay, so for my clarification, like where would you think that would go? Like in the spec or the status, like what object would that be on?
Like we can take like for each given object that you're trying to tackle the life cycle of, we can take
Mhm.
nodes as an example, right? I'm coming this from the Carpenter space. So like in Carpenter, you have actually two objects to track the status of the node. You have like node claims and nodes, where node claims more represent like in-flight requests that are then satisfied by the node. But like for node claims, you have like a set of conditions where you set like when the node goes initialized, you mark it as initialized. When it becomes registered, you mark it as registered. When it becomes like ready, you mark it as ready. And so you already have like a declarative, like in the spec, you can say you could genericize this to an object where in the node you may want to be able to say like there is a life cycle field that you can set to be like, I want the life cycle to now be like drained. And then in the status, you can say like the conditions like drained is not true yet. So you know it's not actually been drained. And that's when you update the status of the object. Why is there like a second? Why are we creating individual events as an object when we could just use the object as the source of truth?
Yes. So in this, the way I describe it here, so we would use the object as a source of truth. And the way I would propagate the state is that it would be through a condition on the node. The only thing that I do a little bit differently with, instead of using like the node status specifically, is I break down some of the other parts that go into like the like setting up life cycle, which is like the claim of like who is the one who should be working on this life cycle right now. So like I call that the claim. And then the other part is like the what, which is like what exactly are we going to be life cycling? So we're going to be going from a draining to a drain state, for example. Like, so the whole point is that I'm leaving some of the breadcrumbs around so that we can have a bunch of the discoverability to understand what happened, who would do it, and then eventually that would make its way to the node on a condition, because we have to, like you said, which is kind of what you're getting at, is that the state has to stay on the object. If we're life cycling a node, the state should be on the node. So eventually, when we do those states, we know who and what. It gets published to the node and on a specific condition that would be published on the node. And so people can reference it and look and say, okay, well, this is a life cycle condition. Here's what it's going through currently right now. And then I can see who's doing it and then what the start and end states are, how long it's supposed to take. So a bunch of the metadata to understand what's supposed to happen.
So the request API that you're creating, kind of, it's what it is, right? Like we don't want to make like I might want to make a life cycle request, change this node to drained or drain this node, right? So the request API is more for, or like the life cycle event or transition API is more of a around for observability, where you would create this, even if you're the one fulfilling it, like you could create this API to be like, I'm going to do this step next, and then do that step next.
Yes, exactly. So, right, we can understand the observability, so we can understand what to expect. I think one of the challenges, like the one of the aspects of this, is that it's observability is really difficult, and it's also, and so like why is that? Because if we were to post say one state on the node, let's say it's like draining, right? What's the next state that I can expect? Um, Technically, if we had like if we wanted interoperability and I gave you the flexibility to choose what that state could be, I'd have no idea what your next state is. You could pick anything you want. And so I wanted to understand with observability, okay, there are two states you can go through. I know what they are, and so I can know what to expect. So essentially, a way of saying that is that it's like a state machine is being broken down into just a single transition. So two states. And that gets sort of, and so what you can do with that sort of single tuple is that you can build a full state machine from it by just going through different pairs of states. So this provides the observability, one of the requirements, provides the flexibility because you can pick any states you want. It provides the structure because we have the certain objects that can express the different states and where we're starting and where we're going. And so the goal of that is like interoperability. We can have different projects use this. It's flexible so that we can have end users who have their business logic can write their own business logic, and we don't have to we can have that exist outside a tree. Does that make sense?
Yeah, I think I'm following now. I'll take a look through the cap, and I think I'll leave some comments here and there. Thank you for the
That'd be
explanation. That
great.
makes a lot of sense.
Great, thanks, Derek.
Walter, you're up.
Yeah, so I mean, I think I almost have counter positive concerns to Derek. So when we say you can have any states you want, I start getting kind of concerned. So I mean, just using what you already brought up, like we have an unknown number of schedulers in Kubernetes, right? I don't think anyone here knows all of the schedulers we use. And so if we then have an unknown number of schedulers, and then we can have an unknown number of, I'm going to call them labels, I apologize, an unknown number of labels for the life cycle that may indicate something to do with draining, I start worrying how we actually get something that's functional like a year from now, right? If we have a prescribed set of life cycle states, I get it, right? Like if we have a draining and a drained, and we're like, okay, we can have other labels, but you got to get them approved, and this is draining and drained, and there are no other options unless you get a CAP approved. I understand how we can move forward, even though we don't know what all the schedulers are that are going to have to now make changes. But if we're like, we don't know all of the draining labels, and we don't know all of the schedulers that may be involved.
Yeah, that's a good question. So I share your concern, Alonso. This is a challenge, and sort of one of the hard things that like with this is that on one hand I could say I could probably name like with reasonable certainty like all the different life cycle events a node can go through. Like we want to drain them, we want to reboot them, we RMA them. I don't know. There's probably a few others. Like we bring them back, we provision them. There's several of them, but there's not like an infinite set. But if you then start to think of like the weird things that people do with their hardware, then it becomes a little bit larger. Like I don't know like how some people do some other things around their nodes or even some of their resources. And so that was one of the things when sort of weighing on my mind is like, okay, we do want to be we want to be extensible, and we do need to deal with like this possibility that end users will want things that we can't think of. And we also have APIs for resource APIs that can come in later that we don't know about. So I don't know how to narrow it down. Now, one point though with this is that I do think there's a way to address this, and I think you did touch on it, which is this idea, and I mentioned in the CAP of reserving certain states. And the example I brought up earlier was like I talked about the Kubernetes scheduler, and particularly like if this was ever to be valuable to the Kubernetes scheduler, we have to be very precise with like the meaning of a state, or it's not helpful, right? There were no way it could ever use it. It can't just randomly learn about all the different states that people want. So my thought is that because there's probably some states that we can be really confident about their meaning, like I think draining's a really good one. Like I think we can be really confident about that we can reserve these states. We can make them, we can reserve specific ones for Kubernetes, and we can have them be very explicitly specified like in our objects to say like, using the domains like kubernetes.io draining, whatever. This would mean that like this is a well understood draining operation in Kubernetes, and this is something that we can integrate into other controllers. So my idea was that we could probably reserve some of those, and those would have some meaning. And then for the ones that I don't know about, that people do that I don't understand, they could still use if they wanted to. But the goal would be what you said, is that find the reserved ones and reserve them, and then build integration around them in tree with the across different controllers.
So, I mean, I'm hearing you now. Sorry, and maybe we have other things to do. In which case, El Mico, like tell me to just to be quiet and go make my comments on the CAP. But so a couple of quick thoughts. One, if I'm in the draining state, I don't want to lose that, right? Like I don't want to have someone else go, oh, I want to be in this other state, which suggests to me that we're not one FSM. We're probably multiple layered FSMs rather than just being one FSM. I will also kind of on a related note suggest that I'm curious, like we keep adding extension mechanisms, right? So like one question for me would be, for some of these, do we need another extension system, or can CRDs and controllers? I mean, I can implement my own version of a claim with a controller and get pretty far. And then the last one, finite state machine. And then the last one I would say would be some of the things you're saying, and maybe I didn't understand what you were saying, but and I'll defer to Joel, who spent more time recently in API machinery than I have. but some of this sounded sort of remarkably like some of the old initializers and finalizers concepts from API machinery. So, where you're like, oh, here is some state transitions that need to happen to do this thing, and there is a list, and you are the first one on the list. You are the one who's going to make the next state transition, given whatever operation, whether it's, I mean, obviously, if it's not initializing or finalizing, but it's still that sort of, here's a state transition that needs to happen. Here's the set of people that normally would be the ones doing it, and this will allow them to all do the right operations in the right order. And I'm just sort of curious, how it differs, at least that part of it, from the initializer finalizer stuff.
That's a good question. I don't. That's something I'd have to explore. I think this is one of the patterns that I've, like you've mentioned, that initializers, finalizers, and there's even another API from the working group Node Lifecycle that's doing something similar, called Eviction Request API. Very similar pattern, right? It's like the list, and we go down the list, and we give people an opportunity to evict a pod in their own, way. So similar concept. I mean, I think like it would be. I would love to hear. I mean, people have the perspectives on that. About the different pitfalls, what do's and don'ts of that. That would be great to hear. But something I can take a note on and do some research on and see if we can build some pros and cons against, as a mechanism. I missed, Alonso, your other question. I'm sorry. It was about the finite, multiple finite state machines, and I'm trying to remember.
So it was an observation with a kind of a question at the end, which is that, Kubernetes is already a very, like every couple of years we add yet another extension system to it, right? And I mean, I remember when we were adding CRDs, and I will just observe that CRDs are incredibly powerful, and I mean, I could re-implement claims with CRDs for the most part. So, I mean, the question is, at what point do we look and go, is the extra complexity really worth, an incremental improvement in the flexibility, given how flexible we already are? And I'm just gonna kind of leave the open question of, why are CRDs and using something like QB Builder to build my own controllers, why is that not enough? And if it's not enough, is there something, is there a smaller incremental improvement which would get me there? I'm not saying API machinery would sign up for this. I'm sure Joel's about ready to throw something at me. But I mean, like, if we said, oh, there's an extension, there's a mechanism to extend Node, and you can add your own fields to Node. Yeah, now Joel's definitely throwing things at me. Like, would this claim, like, exactly? Sorry, Joel.
So that's actually it right there. Is where the challenge with CRD is. So, for the full context on this, a lot of people use labels, annotations, and why they're very flexible. They're easy to use. They have different challenges, specifically like they don't lack structure, and they don't have embedded types. So it's like tough to do like interoperability with them, and also complex things, because like if we had that example of like a 50 node, lifecycle, I mean, that's tough. CRDs, the other one, more structure, so much better. We can use embedded types, and so that's much better. We can also have a custom extension, so it's extensible. The problem is, how do we make it interoperable when we have things like state that is on the object itself, like the node, for example? Like if you're in draining, or if you're not ready, or whatever it is, it's on the node, and you have to sort of mirror the state between the CRD and the node. And this poses a certain challenge. Is like, where should I, as another consumer, be consuming you? Should I be consuming you at the node layer? Should I be consuming you at the CRD layer? And then what ends up becoming from this is that, well, because I'm being very specific, I need specific state on the node. Then I build a bunch of end user logic into my CRD, and this kills my interoperability. So there's lots of examples of this. I mean, even internally, we have a CRD, which we do this, and we run into the same challenge where, like, what would be the interoperability? How could I ever pitch this to the SIG scheduling and say, look, you should use my CRD so that we can do lifecycle management from it. That's sort of the challenge is like, how do I strip away all of the different domain specific stuff to make it work? And that's the challenge. That's where it runs short. Um, the node has the state, which is like I said, extending the state of the node. If I could do that, that would work. But
I hear you, but at the same time, part of me is just thinking back to the old XKCD. We have 13 standards, and what we need is another standard to rule them all. Now we have 14 standards.
yeah, I guess if you wanted to like relate this to something else, it's sort of like what I'm pitching is like somewhere in between taints and CRDs and labels. It's like somewhere in between there. It's like a very specific case that where lifecycle doesn't quite mix in any of those things, and that there's always some little missing piece. Like if for a taint, for example, how could you be very expressive so that's like if we were to taint a node, we could put state in there, but we can't have embedded types. We can't have ownership is another one. Like how would we know like who would be working on the life cycle? So there's like very complicated things that are very specific to life cycle that are missing in some of these primitives. So that's how I look at it. It's like it's sort of like it's one of these, like I said, it is another one, but it's meant to be like it's meant to be different in a few specific ways specifically for life cycle in those use cases.
All right. Great discussion. And I think Walter's new nickname is Alonzo. Right? Yeah, Joel, please.
I wonder if you've had any discussion with SIG architecture about this yet.
I apologize, Joe. I didn't
Sorry.
catch that.
I was wondering if you'd had any conversation with SIG architecture about this yet. So I'm just kind of scanning the KEP. I haven't read it in full, but the thing that strikes me as different, I'm choosing my words carefully here, about this is you seem to be like you're proposing something that's kind of edge driven as an API, where at least apart from events, pretty much every Cube API so far is level driven. So I
Yeah,
wonder if
so go ahead. I can answer. So I haven't talked to SIG yet, but this is something I'm still thinking about and toiling with because you're right in that. Well, the way that it's proposed is like it's sort of it is edge driven. It's sort of imperative in that like once you go to an end state, like that's it, right? Like we're not sort of enforcing the end state of a transition continuously. And so this is one of the things that I've been trying to figure out, and a bunch of different things I've been working on. Like how do I shape this so that we can make it a little bit more declarative? One of the things I've been thinking about is, and I think I mentioned it earlier, like having another abstraction as part of this, where we'd mentioned this like this concept of scheduling earlier, like a larger level API, where if you had a bunch of these things individually, and you would probably use multiple of them, right? Like if you're doing draining, you're probably also going to do a maintenance or a reboot, and then you're probably going to bring your node back. So there's probably some set of things that you'd go through. You would just do one. So that kind of thing, there's orchestration to it, and what we could do is have a larger level orchestration object, and that can be more declarative, where it can describe like what the states that it should enforce and how long they should enforce them before we move on to whatever the next thing that we do. Um, and that would also like have to do with like scheduling and various things. But that's the way I'm thinking about it right now is that this could be imperative, but we can sort of hide the imperativeness behind that, something that actually is declarative.
okay. The other point I'll make now, but I don't want to take too much time, is that so I was reading your user stories, and the first one surprises me that it's even a problem. But that may well be a completely different thing. So that's around graceful node shutdown persistence. I would have assumed the graceful node shutdown was like a re-entrant process, and it just starts from the beginning again. But whatever, that's a different side one. The node maintenance one, there are a lot of different people approaching this same problem from different angles. Um, and I know there's at least one other KEP open at the moment. So are you aware of other open KEPs that are trying to solve the same problem? Have you reviewed how they're solving the problem?
Do you know which KEP is it?
There's
Do you
one
know,
literally called node maintenance.
is it this one right here?
Yeah. So Philip's one that seemed to have timed out.
Yes, so this one, so actually this CAP declarative node maintenance, uh, I this one is meant to replace the declarative node maintenance CAP, and the reason is the scope. The scope for declarative node maintenance is focused only on the node, and the whole idea behind this CAP here was that, well, with DRA has sort of changed the definition of a node, it sort of disaggregated resources. We might want a life cycle, not just a node API, but like a device, like a GPU, a resource,
Mhm.
or whatever else we could think of in the future, like a switch or a rack. Things that like we're going to come up with the workload API that are going to be that we're thinking about for scheduling. We're probably going to need to think about life cycling that as well. And so that's like the other aspect of what I call it as part of the motivation here is like that's complex. And will the existing APIs that we use provide us the necessary precision to do that? That's that's what I'm asking myself, is I'm unsure.
Okay, that makes
Yeah, I want to
sense.
step in here because we're coming up on 15 minutes left, and I think we've given a good discussion to this. I really appreciate everyone here, but we spent probably more than 40 minutes talking about this, and I want to make sure that Nolan gets a chance to talk about his topic as well. So thank you, Ryan, for bringing this. I encourage everyone, especially people with questions, go look at the CAP, add your questions on the CAP, because I think having those in a public place where we can, kind of all comment on them and everything is just, it's good for the process. So yeah, thanks again, Ryan, and really appreciate it.
Thank you all very much. This was a great discussion.
Cool. Yeah, I look forward to see how this progresses. All right. So the next topic, as predicted, Nolan, you've been looking at this AWS job that's been failing. So I'll hand it over to you.
Yeah, so I'm working on a PR, and so are some colleagues are working on other PRs in different parts of the code base for the AWS cloud provider. Um, in scanning um, various repos, it looks like the failures might have corresponded with an update to the Kubekins E2E image, and I was wondering if anyone had any insights off the top of their head. Like the errors seem to be complaining about kubectl not being installed. Um, so I wasn't sure if anyone's seen this before, or if I need to keep digging.
I mean, I've seen it before, but only because I've been looking at that failing test for, for a while.
Okay.
But I've never understood what that SSH error that it was throwing up there was like. What I could never figure out what
So
exactly was happening there.
so if you go back to the job history, if you pick one of the failing PRs, and you scroll down, so the SSH error is actually that's transient, that happens in the passing cases. If you scroll further down to yes, we're getting commands failed. No kubectl is not found. We have these varlog pods not found. Like it looks like something's very wrong with the image. Um, so
Right. That was my.
it
I was like, why is it coming up? kubectl not found.
right. So I wasn't sure if anybody knew of any changes to the Kubekins ETE images. If not, I'll go probably bug the testing SIG or infra folks, because I'm not familiar with that build process, but looks like it coincided with, I think, the 135 dot release, possibly somewhere between January 23rd and February 13th. Um, so yeah, I was just curious if anybody else has seen it and had an idea, but it sounds like not, so I'll keep digging.
Yeah. So whatever happened in that couple week window between January and February, I don't know. I mean, do we think this is something? Well, I guess yeah. It has to. We have to look at that image. I'm not even sure how that image is generated or where it comes from. So we probably have to.
Right, neither am I.
Yeah. I guess if nobody else has an idea either, then we might want to go talk to like SIG testing or SIG Kate's infra to
Yep.
see if like we could get a little more information about where it comes from. Because I guess that's the next step is just look at these
Okay.
images and figure out what's going on there.
Yeah, and I actually have a thread in the cloud provider AWS Slack channel. I'll throw that in here actually. I will. I'll take that and go ask them because I did find uh some test infra um PRs that would have coincided there, but I'm not sure they're the correct ones.
Okay. Well, I mean, like, I don't have anything more to add, and I don't see anybody raising hands.
Yeah, no,
Um,
that's fine. I think we've
yeah,
covered it.
yeah. So unfortunately, this is just going to require more, yeah, probably more investigation, and we'll just have to keep digging until we can figure out where, yeah, where those things are being generated and what we need to change, if anything, to start fixing it. Thanks, Doc.
Yeah,
Thanks, Doc.
I
Oh, sorry. Go ahead.
no, I was just thinking that like there was some test infra changes, and I remember we making at least I was reviewing or making some changes to fix the cops test cases. So maybe this might also was they affected. Like we need to dig to see what changed because at least on the cop side there are few things changed on the infra, and we had to fix those tests. So yeah, but even I am not aware of how the exact way this image is built. But yeah. It will take a bit more deep to understand because because January was a time when there was some changes in the test infra, and I think we had to make fixes in most uh, uh, test cases which are running on AWS, like in Cloud Provider AWS, and also in the scalability tests which are running on the KK repos.
Yeah, thanks, Keith, and I appreciate that. I guess like that's the other question too, right? Is like, given that we're looking at when looking at some of the messages up here, um, where was it? I thought there was something about, yeah. So like it's given that it's looking for these EKS logs and everything, like what do we know is the base image, theoretically the base image for this test should be it should generate a new Kubernetes image, take the take the binaries that are created from that and lay them into the image that gets created. So we might need to look at for since this is coming out of kube test 2, like how it's wrapping that and putting those things in there. Like if and I didn't think there was a deployer for AWS. So I'm not or EKS. So I'm not sure which maybe it's using the no-op deployer, in which case I'm not sure how it's building. The no-op deployer allows you to just pass a kube config through. But there's no like build step for it. So we might have to figure out like how this is being automated in a way. Like for example, if we're testing on GKE, there is part of this process where it builds the Kubernetes image and packages it and builds all the binaries and everything, and then packages, it stores them here and packages them up in a way that when we go to actually run the tests, um, there is this, where is Kuba? Come on, Walter, help me out here.
Do we still have Cube up here? I thought we had finally gotten rid of it.
You just saw it here the other day. Anyways, there's a script in here that will
Um,
take the tar file and put it into the thing that's created.
can you go up a level? Because yeah, sorry. Yeah,
It's
Cube up is here.
Yeah. Oh, there we go. Yeah. So in here is where it like it can take the binaries and then inject them into the image that it's about to run. So like we might need to follow this path to figure out for a job running in EKS, if we're using kubetest 2, what kubetest 2 deployer are we using, right? So like which are we using just the no-op deployer or something, or are we using something else? And then how are we injecting how are we building and injecting the binaries? Because theoretically, those binaries should be built from whatever commit is being tested in KK. The binaries then would be injected onto the image that is being run, and then the test would be run from that. So I think we need to follow that chain of logic, basically. I'm not sure that helps you or not, Nolan, but we could talk about it more offline if you want to.
Yeah. No, that gives me some things to look at and a place to start. So thanks.
Yeah, I might start by looking at like how how is this job configured in Prow or whatever? Like, how are we executing kubetest 2? And then start to walk through that chain. Because ultimately, like I said, if we were doing this like on GCE or something, it would go into here and it would build the image and turn it into a tarball that then gets, that then gets consumed, when it's actually running the test. And right before it runs the test, it consumes that tarball and puts the binaries into the Kubernetes it's about to run, right? Or the cluster it's about to make. So presumably something similar is happening in EKS as well. We just need to follow and figure out where that's coming from. Okay, any other questions or comments or thoughts on that? Okay, thanks Nolan for bringing it up and Kirthan as well. All right, so the last thing here is for me. I'm gonna merge this. There's been no updates, so I'm guessing we're in good shape. Uh, so yeah, if nobody has any objections, I'm going to hold cancel on this, and we should have
No
our.
objection. No
All right,
objection. This is all good. I think you have it in good shape.
cool. Yeah,
Thank you.
I wanted to leave it open in case others wanted to
Mhm.
come and
Sure.
add stuff, but yeah, I think we got everything we need. So thanks.
Awesome. Thank you.
All right, cool. So hopefully that'll get merged and we'll be a couple days ahead of time for, getting this into the, getting our chores done, as it were.
Wonderful.
Okay. So before we end here, let's take a look at our periodic. Let's take a look at our open issues that need triage. I think one of them came back up for triage. Okay, well, we've got this one to look at, this one from.
And while he's pulling those up, by the way, Joel and Walter, if you want to both look at your DMs, we're doing a little bit of juggling of schedules of stuff for KubeCon that if you want to make sure that since I have you here, I want to make sure we get an answer from you before we all get too busy.
Yeah, no,
You can
good.
just answer in chat
Good
or
reminder.
you can answer in DMs, but thank you.
So this one came up the other day as a question of being a blocker. I looked at it and I did not think it was a blocker. And more to the point, when I looked in to the code around this, it seemed like a flake was happening in this test. So I'm not sure what the next best approach is to take here. But is anybody interested in investigating this further, I guess? What happened here in the test that I noticed was that during a point where we're not expecting to get any sort of responses from the API server, or the API server is not expecting to get any sort of actions, there is a watch request being created on nodes at a time when the only thing we were doing is updating nodes. So I'm not quite sure why it did that, and it only did it once in one of the tests. It didn't seem to be pathological. Um, so I'm not sure I guess what is the next best approach here? Do we accept the triage on this, and then I guess what do we do?
I mean, I think we can accept, but I would also just put what you said in. And if we think this is a once in a blue moon event, maybe we just say, look, until we see a recurrence, we're not going to prioritize this, right? I mean, I think it's better to just be pretty open with our communication.
Okay. Yeah, I think that's good. All right, so I guess we'll accept the triage on it. And then maybe say like, we'll come back in 2 weeks and, if there's no more failures around this, we might just close it at that point. All right, the next one, service controller memory leak. Last syncs nodes entries not cleared when services are deleted. This sounds like a good one. Oh, this is in Kube Controller Manager. Oh, in the cloud provider service control. Okay. This definitely looks like it should be investigated. Does anybody want to follow up on this, or does anyone want to look into it? I think we should triage accept this. I don't necessarily have time to look into it personally.
Hey, can you see if you can assign this to Aaron Prindle?
There's a typo in the accepted. Sorry.
This Aaron
Yeah.
Prindle?
Yep.
Okay. Thank you, Walter. Okay, the last one is an issue that I generated about over a year ago. This is just I think we all agreed on this, but we just need to kind of follow up. Essentially, there is this, right? There is a repo that we call like the cloud provider, sample, right? And this sample is badly out of date and doesn't actually contain anything that you could sample with, right? But we do have a sample that's actually in the cloud provider repo that does give a basic sample. So essentially, I PR'd this to say we want to do this, but the question is, are we okay archiving, this repo? Does anybody mind if I start the process to say, okay, let's just freeze this repo. We're not going to use it anymore.
When you say
never had any-
archive, yeah, so when you say archive, you mean the process on GitHub to archive, not like delete or anything that would
No. Yeah, like I'll request to the Kubernetes GitHub team
Right.
archive this repo so that
Yeah.
it no longer can take, submissions or anything.
I think that's a good idea.
We had 8 years to put a sample here. We chose to put it somewhere else. So
Yeah,
okay,
I think
cool.
that's a good idea.
Yeah, if there's no objections, I'll kind of move forward on that. And I spelled accepted properly. And I guess we're a little over time. So if people have to drop, please don't feel bad about it. Okay. I think that's I'm just gonna check our oh, it already merged. That's cool. I'm gonna check our bugs for our periodics here, and if that looks good, we can call it a meeting.
And I think we'll see people in 2 weeks at this call, but I believe we'll probably cancel the one on March 25th in
Yeah,
4 weeks because
that is a
that
great
one is during KubeCon.
Yeah, we will not attempt to hold this meeting during KubeCon. Although, like, that would be funny. Although stressful. Okay, so we have one failure there. Oh, a couple more. Let's see what this one is. I'm guessing this is kind of a flake. Okay, I'm happy with that. Alrighty. Thanks to everyone who stuck around to the very end here. And yes, we will see you all again in 2 weeks, or those of you who would like to join us. All right, take
Wonderful.
care, everyone.
Thanks. Take care.